Hi there. My name is Schott, and today I want to close out CascadiaJS by talking about what's next for JavaScript. And I want to start with a video that I truly, truly love. I love so much about this video because it is a perfect explanation and kind of illustration of how we as humans approach a new technology, especially we as developers. And what this is a video of, so it's July 17th, 1936. And for the first time ever, NBC is doing a live television news broadcast. So television news, it's happening. They've never done it before. No one's ever done it before. TV as a concept is fairly new. It would be years until anybody does any sort of regular television broadcast. So these are truly, they're trying something new they've never seen before. They have no model to base this off of. The only model that they have is radio, right? Radio news being the common way to get news like this, even close to like this. And what I love about this video is you can just tell they don't really know what to do with the new technology, right? They're radio newscasters, they're being recorded, but their best kind of take on what to do is, well, let's just record ourselves doing the radio show, same as we always do. There's no sort of changing of what the form is, the format for the medium. And so you can just see like how relaxed they are. It's the video, the sound doesn't come through, but essentially they're just congratulating themselves for how impressive they are for doing this. But once they get through that, you'll see in a second, the guest just kind of like gets up and says like, okay, I guess it's time for me to go. And looks so uncomfortable. He's never done this before. And you realize how much of the form of radio is built for not being able to see what's going on. So they have to narrate everything they do. I love this. You can see him just kind of, all right, well, I guess I'll go. And he kind of tries to give this like really inspirational little speech. It doesn't really land. He walks out the door on the stage. Camera is still rolling. Meanwhile, the host reaches in this little box, pulls out a cigar, lights it, starts smoking because why not? This third person comes in. He's not the guest. He's just telling the host that the guest has arrived. Send him in. And you realize that there's this whole song and dance designed for radio. And what they've done is take that exact same form and bring it to TV and not really think about, well, do we still need to do any of this? It goes on, and I'll skip over all that, but the point of this video to me, and what I love about it so much, is the realization that disruptive technologies like television for the news, radio to television, part of it is the technology and how impressive and how much that can change things. But it's equally about the new ideas and using that new technology appropriately, using it in a way that suits the new medium or the new foundation. The first thing we do when we see a new technology as humans is try to fit it into our existing worldview, right? Our current way of thinking. I'm a newscaster. I read the news into the microphone. Why wouldn't someone want to just watch me do that? And that's the news now. Completely, missing that the form has changed, right? You don't need to narrate. You don't need a song and dance. It's weird to just be sitting there for seconds on end, lighting a cigar while this random strange person comes in and says like you're a doctor, someone is here to see you. We fit the new technology into our existing world instead of asking how would the world look different with the new technology. And to be fair, different doesn't always mean better, but different is different. And I start with this talk because I want you to watch the rest of it. Or I start this way because this framing is important. We've just seen a whole conference of some really impressive talks on really impressive technologies. Some of them probably as disruptive to web development today as television and recorded video was to these newscasters. And let me tell you from experience, over the last decade, that has not always been the case. And I say this as a React developer. I love the ideas, but we're clearly entering some new time. There's really disruptive things going on. And for the first time, we are starting to re-examine our way of thinking with these new technologies. So I want to spend the rest of the talk talking about what comes next, what comes after React, what comes after Webpack. And I'm not someone who has all the answers. I didn't even coin this phrase, the third age of JavaScript. It's just a phrase I really like, but I do spend a lot of time thinking about this problem and thinking about this question about what comes next. I created a project called Snowpack to explore this question, which I'll talk a bit more about in a bit. Pika as a project you might have heard of, Skypack. These are all projects that I work on and are really exploring this question of what comes next for web development. But the third age of JavaScript, what does that mean? That is actually a phrase coined by Sean Lang, a great kind of person who just kind of loves throwing these questions out there. I love this piece that he wrote because it basically set out to catalog some of these changes that he was seeing happening in the JavaScript ecosystem and trying to put them in a kind of historical context. Because things are always changing, right? But usually in smaller incremental ways. You can see on the timeline, right? There's always something new coming out. But every so often something changes a lot, right? There's almost a shifting of perspective. You can think of these big ideas that come along that really kind of captivate us for many years. React, Node, Webpack, big foundational ways of thinking, not just technologies. And Sean rightly predicts and saw that we are entering one of those moments right now. And I love this piece because Sean doesn't claim to have all the answers. He basically just invites you as the reader to fill in the rest of the slide for yourself. And if you've never thought about that question before, go ahead and take a second. It's a kind of interesting question. What do you think the next decade of JavaScript and web development looks like? And if you can't pause the video, then because it's a live stream, I'm sorry, just think really fast. Sean ends up predicting, kind of towards the end of his piece, that the last stage of JavaScript is all about clearing away legacy assumptions and collapsing layers of tooling. So that was his take. Overall, pretty solid take. Less legacy, less kind of disparate, disconnected tools. Sounds pretty good. I would definitely take that. But for this talk, I want to go one step further, and I want us to try and understand what's actually driving these changes. What's going on that's so disruptive to cause this new age of JavaScript. And then from there, once you have an idea of what's changing, gaming out what will change it becomes a much different question. It becomes how are the implications of this change? You can start to kind of sketch out where you see the world going. And so again, this is something I've thought a lot about and something I care a lot about. And my answer to this question, what is changing, what will change, and what will define the next decade of JavaScript is ESM. The third age of JavaScript is all about ESM. And this is the period that we're entering right now. The largest software migration possibly in history is happening right now, and almost nobody knows about it. That is a massive change that has implications, that will stretch on for years. If you don't know what ESM is, that's totally fine. You might even have used it and not realized it. It's essentially this syntax. Import something from this file. What's interesting about it is that it's built into the language itself, right? So this is not something provided by anything other than your JavaScript environment, your browser, Node. It's baked into the language. This is a bit different than past module systems that have been popular. CommonJS, which was popularized by Node and NPM, very similar looking, but a little bit different. It's not built into the language in the same way. Before we had that, it was much more of a Wild West mentality. Maybe you brought your own module system in, or maybe you just pulled things from this window global scope. But what I love about this is that this maps almost perfectly in terms of what was popular at the time to Sean's timeline. And one of the reasons why I think ESM is so transformative is because it fits into this model, this idea that the lower level of how we build things, right? The lowest foundation of a module system the technical implications of that end up defining what you build with it, how you think about what you're building, what your tooling can do. Going from a kind of disparate, disconnected world to CommonJS as a system, and then now to ESM, those are foundational changes. And the fact that we're in the middle of this one is really important to understanding what comes next. So I want to quickly step through these because, again, what we build is totally influenced by the tools that we have. The first stage of JavaScript, again, if you were doing web development at the time, it just was a bit of a mess. You'd put scripts everywhere. Maybe at a company or at a larger project, you would have your own module system, something like require.js, but this would be totally you creating your own structure out of nothing. You weren't given any primitives by the browser or by your JavaScript environment. Node was really the first environment to prescribe a module system. So CommonJS, this idea that you have a require function and it can load different files, and you suddenly have a one single true module system for any Node project. This ended up being really popular even with web developers, where that syntax, that require function, would never actually work in the browser, right? If you imagine how that works, it's instantly needs to respond with the contents of this file and then the actual parsed, the module itself. In the browser, that would mean that every time you got to one of these loading statements, you'd have to stop, resolve it, go make a network request. This is a function call that responds, basically has to block until it's done. So this was never meant to run on the web. That's what led us to the current world of tooling, which is really about taking this language, this module system that doesn't run in the browser, and trying to make it run in the browser. First it was Browserify, and then Webpack, Parcel, Rollup. All of these bundlers are really about taking code that was never meant to run in the browser and making it run in the browser. There's performance implications. It's a good idea to bundle for performance, but the difference between those two ideas is that it's required. This isn't just a performance optimization. This is a required way to take code that doesn't run in the browser and run it in the browser. That's really dictated the whole last decade of JavaScript. And if you really think about what that's meant, it's meant that we've been building on a very tooling-heavy foundation. A foundation where to get started, you need to pull in a bundler. You need to build on top of this, this foundation that is not necessarily about sending the code that you write to the browser. It's about taking the code that you write, processing it into something new, and shipping that to the browser. I think that a lot of our JavaScript fatigue, our JavaScript is alienating, a lot of these stereotypes that I don't think are true, but I think they come from a place of our foundation is complex. For a language that was never meant to be compiled or really thought of in that way, it was meant to run directly in the browser. We have built ourselves into this world of tooling that's been hard to find a way out of, and we've just been kind of incrementally building on top of ever since. And so that brings us to the third age of JavaScript, right? This idea that there is something new coming. There is ESM, right? It's going to change the world. It's going to change the way we think about JavaScript. Everything that's old, throwing it out, we're starting from scratch. This changes everything, right? And the first thing to realize is no, it doesn't, really. We have these different module systems that really, they look very similar. As an author, right? They're basically following the same format. I want to load this thing from this file. At the end of the day, that's pretty much the same number of characters, the same basic concepts. It's really easy to look at this and say, I don't get what the big deal is. These seem really similar. But remember the trap, right? Remember the human instinct to take a new technology, and instead of evaluating it for what it is, we try to fit it into our existing world. For this talk, I want to explicitly not do that. I want to literally throw out everything you know for the purpose of thinking about this. And what would it look like? What would our world look like if we designed it for this new technology? And the thing you realize, the important thing about it is that for the first time ever, we have a module system that runs natively in the browser. Everything we've done up to this point has been about taking code that wasn't meant to run in the browser and running it in the browser. Our whole foundation of tooling is built on that basic premise, is that we need to do that before we can do any sort of other things. We are moving from a required tooling heavy foundation to one that is completely optional. And so the question then becomes is then what would that look like, right? Okay, so less tooling is required, but do people want no tooling? Do people want some tooling? What would that, that's its whole other question. Given a new technology, what does the world look like that's designed and optimized for that? That's what I want to end on today, is a look at what the future of JavaScript development might look like. And it starts with a project called Snowpack. This is a project that I started about a year ago to really explore this question of what if you redesigned web tooling, assuming a world of ESM, and what could you do if you got rid of bundling as a developer concern and purely treated it as a production optimization. And it turns out you can do a lot changes when you make that jump. For one, because you're shipping files individually to the browser, there's no upfront cost to starting your dev server. We see server start times of essentially 10, 20, 50 milliseconds on most runs. And that's really cool because it basically means that we're just shipping files individually unbundled from your disk to the browser. Now, usually developers want to use JSX or TypeScript or React, and these are things that need to be compiled to run in the browser. So we're not purely a no JavaScript tooling world. We're just building each file individually. So instead of bundling and building at the same time, we just build during development. And what that means is that we end up shipping files individually to the browser. So I don't have time to demo this, but I do want to show when you open up your application in the browser with your dev tools, you see individual files going through here. So you can see React, you can see your index.js file, you see your app.js file. That was a JSX file that's been compiled. And likewise, your CSS, if you import CSS, that gets added to the graph. All of this happens so that you don't have to do any bundling. We're shipping files over to the browser, and then everything just loads. You see there in the time column, really, really fast. So fast startup, fast first load, and because each file is built individually, we cache them individually, which means that you only ever need to build every file once. We will reuse that build basically till the end of time until you change that file. So let's say you go in and change a file. All we had to do, and we didn't have to rebundle, we didn't have to remake entire chunks of your application. We just rebuilt that one JS file that you changed and then shipped that to the browser through HMR, so through hot module reloading. We essentially, in 50 milliseconds, went from you saving a file to seeing that reflected in the browser. So part of that is the amazing work done by the React Fast Refresh team, but part of that is just the fact that we're doing a lot less work. A way to illustrate it, which is really simplified, I don't think this is 100% correct on a technical level, but it's a good way to think about it, is that what Snowpack's able to do is every time a file changes, we just build that one file. So there's no bundling work to be done. And bundlers are in a really interesting place where WASM and Go, if you've seen the project ES build, there's really interesting things done to bring bundling to the next level of performance, and that's awesome. But what's great about Snowpack is we're not trying to be the fastest bundler, we're just trying to remove that chunk of work. Every time you change a file, we build that one file and then that's it. Really small builds, really singular amounts of work. As you saw in that example, 50 milliseconds between save and seeing that update. 50 milliseconds to start your dev server. That's the future of web development. And then when you go to production, that's when you bring in the bundler. The end result for the user is still the exact same thing, but the result for you as a developer is a much faster dev environment without sacrificing functionality or ability. That's just a really quick summary of Snowpack. Check it out at snowpack.dev for more of what we're doing and what we're building towards there. It's a really exciting project. The last thing I'll end on is our other project, which is Skypack. So you can already see the Snowpack, Skypack, we clearly got a theme going on, but the idea is simple. It's everything on NPM delivered directly to your browser as ESM. So don't think of this as just another NPM CDN. This is actually taking a pretty interesting stance. Every package, no matter how it was written, is built and hosted as ESM. So you don't need to know anything about what this package looks like. You just know its name, and you can write an import that will run anywhere. It'll run in Snowpack, it'll run in Rollup, it'll run in your browser if you run it directly. If you go to skypack.dev, you'll see any package, you can load up a REPL and basically just run that package as you'd like. It's a really interesting tool. And again, I wish I had more time to show it to you, but check it out at skypack.dev. It's this future idea of ESM, available anywhere, runnable anywhere. Using only the package name, you get what you want. So that's a quick summary of where we see the world going. This idea that you can import anything from a URL is really powerful. And Snowpack unlocks the dev environment, instead of being this heavy tooling workflow, something really lightweight. I really hope you enjoyed this talk. I hope you enjoyed the conference. You can learn more about what we're doing at snowpack.dev. And I can't wait for how the next decade of JavaScript evolves. And hopefully, proven right or wrong, it's exciting.
Yay!
Woo!
Woohoo! Thank you
End
so
of the
much for that.
conference!
Yeah! Oh my gosh. I'm kind of like, but also woo.
I know.
Also, Man, thank you so much for that. I feel like the entire time I was like, ooh, It's all of this sounds so interesting to me, and I want to start so many projects to experiment with all of this. So thank you so much for that talk.
Of course. Thanks for having me.
Yeah, we've got a ton of questions for you, so I'm just going to dive right in because I don't even think I got all of them. They're kind of pouring in here. So the first one, top voted one, where does WebAssembly fit into this new world? And does it? I know you slightly touched on it at one point, but not very much.
Yeah, that's a great question. I don't think that's like a question that's been answered, so I definitely don't have the answer to that. I could take a stab at it, which would be that I think it plays a big role. Where it's seen a ton of success, and I mentioned a project called ESBuild, which is a great example of where it seems to be fitting in really well today, is taking a really computationally heavy problem that we've been using JavaScript to solve, and then solving it with a native compiled language. So I think that's written in Go. And if you go check out the project ESBuild, it's called, that's the letter E, the letter S, the word build, all one word. They have comparison graphs of like it compared to Rollup and Webpack. And it's like every JavaScript tool is like a bar this big. And then ESBuild is just like that. It's like anything that's really computational heavy, it seems to be doing a really good job of. How that impacts web development, I'm still not sure.
Yeah, a lot of this, I'm kind of like, ooh, Galaxy Brain, this could make my web apps amazingly fast, but how much faster? Is it that much faster?
Right.
Will my users see that much of a difference, So
right.
ROI and all of that for sure. Okay, there are many other questions. I can't comment too much. Does this support delayed downloading of modules that aren't needed just yet?
Oh, that's a good question. Let's see. So there's an interesting question here where Snowpack is all about sidestepping this question, which is like, well, what about the performance of modules? And we say, no. This is a dev tool. If you really care about performance, you can keep bringing in a bundler, and the end result for your users is the exact same thing. The dev experience for you is like amazing. But that's not to say that we don't care about the module ESM performance story. One of the things that we're working on now is this ability to basically preload everything in your application, basically sending that information ahead of time with the HTML in the final build that we generate, so that you actually can ship an unbundled application to the user. And essentially they get a full, you can think of it like a manifest of everything that they'll need, every file down their kind of import graph, but delivered immediately so they can start downloading it immediately. There's a lot of work still to be done there. So it's a really interesting question. But our short answer is if you really are worried about performance, nothing's stopping you from keep using a bundler for production.
Yeah, interesting. Ooh, I can't wait to research more on that. Next question, how does versioning work for Skypack?
Oh, great question. We use something similar to if you've used Unpackage, where we basically will respect semver. So if you put in a package name alone, no version, we will pull in the latest version, the most up-to-date. But then you can provide a semver, so like something like give me a range of versions, give me the most recent update since then. We have some documentation on skypack.dev that lets you basically, like you do today in your package JSON, set a range that you'd like. And then we honor that. We will essentially lock that down for you with something we call pinned URLs, so that you can then rely on that URL. It'll never change after you've deployed. You can kind of trust that it isn't going to change on you after the fact.
Interesting. Cool. What are your thoughts on new built-in libraries like Iterator or temporal proposals?
I don't know enough about them, and I wish I knew more.
Yeah.
They sounds very cool.
Yeah,
I'm not enough to comment anything meaningful. It just sounds, that's a great name, temporal.
Sense. Yeah, it seems like, I don't know, a spy library or something.
How could that not be a great proposal?
Yeah. So this question, if ESM is the way to go, why does so much Node.js still, even in the most current version, need you to still use CJS, require, and all of that? And most of Node.js team will go on and on about how require and CJS is so necessary.
Yeah, that's a very big question. I would say that the very short answer to that is, don't think of this think of it like a migration. Node has decided that they're going to move from CommonJS, which they really standardized, to ESM, which is the much more kind of open, every browser environment is going to support this going forward, so why wouldn't we? That is a really hard task, so they get all the credit in the world for taking that on. But think of it like a migration. Like they're doing so far, they're trying not to make the same mistakes that like a Python 2 to Python 3, where the whole ecosystem got cut in half. They're trying to do this in a pretty slow moving, but I never noticed it kind of way.
That makes sense. And that kind of reminds me of how the React team recently released React 17, which was the no new features release. And everyone was like, what's the point? But it's incremental changes, so that way you don't end up completely severing the ecosystem.
100%. Yeah, it's tough to pull off, but when you do, it's a pretty impressive feat.
Right, for sure. So what kind of speed increases can we expect to see by all the packages from a CDN that are hopefully cached instead of downloading a bundled file?
Yeah, that's one of the things that's most exciting about it. We basically do all the cache optimization for you so that you don't have to worry about it. So if you included one of these Skypack CDN links and loaded your application actually in production, pulling these files in, you just expect your user to basically download it once and then it's cached forever. So they come back in a month, a year. If their cache is still full of this file, they're essentially revisiting your site a year later with the same version of React. So if you haven't upgraded that one dependency, you're still good to go. It's this idea that we're 90% of your foundation. If that's your NPM packages, you can make as many deployments and redeployments of your source code as you'd like. But if you're not changing those packages, then they stay locally cached. You don't even have to make the request to the CDN. They're just already on your machine. So your site loads really fast on a second, third, 100th visit.
That's so cool. Man, I could talk about this awesome. So long, but we are out of time. Fred, thank you so much for your talk. It was so interesting. I can't wait to play with all of these tools, and there's so many link dumps in the chat. I'm just going to be scrolling for a long time. But thank you so much again.
Thank you so much. Congratulations on a successful conference. Successful MC.
Hey, y'all, we made it. That being said, we are off to close out day 2 of CascadiaJS. Take it away.